Hey everyone, welcome back to our TradeX Spring Boot backend series. So in the previous video, we have completed one of the most part of our JWT authentication. That was our JWT service class, and we learned that uh, how we can generate a JWT tokens, and we also understood every method inside the JWT service class, and we have also seen how the token is expired and how it is checked. And finally, we have verified whether the token is valid or not. So, but if you think about it, there is still one question is unanswered, and that was who actually calls the JWT service. So right now, our JWT service knows how to generate and validate the tokens, but no part of our application is actually using it. So a user can still log in without using a JWT. So our authentication system is still incomplete. So to build a complete JWT authentication system, we need some additional components. So here are the components. So this will basically our roadmap, how we are proceeding during the our upcoming videos. So in last video we have covered the JWT service, and in this video we are going to see the second part, that is custom user detail service. So let's see what it is. So imagine a user. Now user will send some login credentials like username, email, and password. And now it will reaches to a Spring Security. But now our Spring Security will confuse that where this user is stored, means from where I have to validate it. So in our system till now we haven't specified any method that will verify the with the user. So for that purpose, we are introducing this new class, that is custom user detail service. In this class, user will send the details to the Spring Security. Now Spring Security will give these details to this particular class. And now this class is responsible to load the users from the database. So here you can see the actual flow of the code. That is, first user will login, then it was sent to the customer user detail service, then it will load it to the user repositories, then it will go, request will be further proceed to the database, and then the user will load it. So now let's see actual what code we have to see. So let's create the file. Yeah. Um, Basically it will implement the method user detail service. Okay. Now let's register this class as a service. Then also this will require element constructor. So now it will our Lombok will create the constructors automatically. Now let's create a private final variable. Now this repository will communicate with our database. Final means it is initialized only once. So to save the video time, let me code. Then after the coding part was done, I will explain you. We have injected the user repository. We will use this repository to search the user in our database. Then this is the most important part. that is the load user by username. And here we are referring our username as our email because we haven't uh, created any specific username for the account. Here we now here we search the database for the using the email entered during the login, and if it is not found, then it will just throw the this error, and with error it will also return the email. Now, after creating this file, we are getting error because that service is expect to return an object of type user detail currently, but our user entity doesn't implement that interface. So to solve this, we will update our existing user.java file, that means user class, instead of creating the new one, old file of user class. Then let me modify it, and after modification, I will come and explain what modification I have. So the first most important change is that now our user class now implements the user details. So user details is an interface provided by the Spring Security. So it defines what information every authenticated user should provide, such as username or password. Now the next change is we have added method for get authorities. So this method will tell our Spring Security that what permission this user has. Now, a grant authorities will grant authority represent a permission or a role, and simple grant authority is a Spring Security building implementation for storing the rules. For now, our role in the database is user, but Security expect that it is in the format of a role slash user. This is the prefix and then our role. Now it will identify automatically what exact the role is. Now Spring Security asks for the username during the login, and we are treating email as the username. Now these are the methods like is account not expired, not locked, and is credentials are not expired and is enabled. So these are the methods that tell Spring Security whether the account is active, unlocked, or enabled. Now our project doesn't support the feature yet, but we simply return true for so simply return true for all. We will implement later. One more thing that I want to highlight is that we are returning here the list of that is it will create an immutable list containing the user role. And also the return type of this method is the collection. Basically, collection is a group of objects. Since a user can have multiple roles, so this method will return a collection of the authorities. Now, we have upgraded our user entity to implement the user details. Then, but still now, if we run the application now, our Spring Security still doesn't know what exactly these classes, why these classes exist. So now our next goal is to connect the component. So let's see. So till now, we have completed JWT service. Then we have also completed the second part. Then we have just updated the user entity. And now our goal is to see what actually the security.config is. So you can use one analogy that we have let assume that JWT series is as a CPU. and customer user as a RAM, and user entity as a motherboard. But to form a computer, what we need to combine these all components. So the responsibility of combining all these components to form a computer is of the security config. So security config is responsible for connecting these components. So now let's understand the complete our flow. So basically, whenever a client will send a request, it doesn't directly reach to our controller. So first, it enters in the security filter chain. So here's Spring Security performs all the authentication and authorization checks. And if everything is valid, only then is the request forwarded to our controller. So before writing the code, let's understand a few important concepts that we will use throughout this. First, configuration. So basically, this will tells Spring that this class contains the application configuration during the application startup. So basically, this is the annotation. Then the main, then the bean. So bean is simply an object that is created and managed by the Spring IOC container. So instead of creating object manually by using the keywords like new everywhere, so Spring will create one object and share it everywhere it is needed. Then the password encoder. So now the password should never be stored as a plain text inside the database. So instead we will use decrypt to convert all password into a secure hash. So during login, Spring hashes the enter password login again and compress the hash instead the decryption the password. Then the authentication manager. So this is responsible for managing the authentication process. Whenever user tries to log in, Spring Security sends an authentication request to the authentication manager. Now, the authentication provider. So the authentication manager doesn't verify user by itself. Uh, Instead, the responsibility is of the authentication provider. Then the DAO authentication provider. Since our users are stored in the Western databases, so our Spring Security provide the DAO authentication provider. Authentication provider. So this provider loads the user using our custom user detail service class and verify the password using the password encoder. Then the security filter chain. So this is the one of the most important concept in the Spring Security that every incoming request first enters this filter chain. Here Spring decide whether the request is allowed, blocked, or required any authentication before it reaches to our business logic. Then the stateless authentication. Unlike traditional session-based authentication, JWT authentication is stateless. So this means the server never stores user information. Instead, every request must contain a valid JWT token, and the server verifies that token independently. CRP. So this is mainly required for the session-based application. Since we are using JWT and not maintaining server-side sessions, so we will disable CSRF. Then authorization rules will come. So basically, request matches. So this will use request matches like a syntax that used to define which APIs are public and which require authentication. So for example, login and registration API should accessible without authentication, while profile, wallet, trading API should only be accessible after the user has logged in. Then finally, we will register our JWT authentication filter. So this filter will execute before Spring Security default authentication filter. So it will extract the JWT from the authorization header and validate it and authenticate the user before it reaches to our controller. So now let's move on our actual coding part. So for that, we need to create a class in package name config. Here we can use file name as security config. Okay. Now, first, what we need to do, we need to declare it as a configuration. Okay. Then we also required the required argument constructor. So now it will automatically create the constructor. Now let's inject two dependency injection. The first one is so here I have injected two dependencies. So before moving, we need to also create one service for JWT authentication filter. So I have injected two dependencies. First, we will also require to create this class in the security. Okay. Okay, so we have created. Now we back to our security config. Now we are trying to importing it. So we have created it. Now we have to mention that it is the component. Okay. Then after declaring component, let us back to our security config and try to importing it. So yes, now we are successfully imported. So after this, um, we have to create our first bean, that is the password encoder. So we are using the decrypt password encoder. So for that, mention bean. Then we are creating one method for password encoder. Okay. Then this okay, and this will return a new decrypt password encoder. Okay. Now string hash the entered password and compare it with stored hash using this. Now the next part that is the authentication. So now let's get another view. Now we need to create for the authentication provider. Okay. So instead of uh, going through coding line by line, this will take too much time. So I will complete this method, then we'll explain to you. So now, basically, this component is responsible for verifying the user credentials during the login process. So here we are using uh, the authentication provider. Since our users are stored in our database, this provider is the best choice for us. We are passing the custom user detail service to it to its constructor. so it knows how to load user details from the database now. So now we are using the latest version of Spring Security. So in this latest version, we can pass the service like this, like user constructor. Otherwise, in the old format, we have to call some new extra class, and from that class, we are passing this. But this is the updated approach now. Next, then we will configure the password encoder. This tells provider to use decrypt set decrypt when comparing the password entered by the user with the encrypted stored in the database. Next, we will configure the password encoder. Then finally, we are returning the configured authentication provider as a Spring Bean. So Spring Security can use it. Uh, Now, I will create the authentication manager. Um, so now I have added authentication manager. So whenever a user will log in, Spring Security delegates the authentication request to this manager. Now this manager will return instead of creating it manually. We obtain now the default authentication manager. Now I have created authentication manager. So whenever a user will log in, Spring Security delegates the authentication request to its manager. So instead of creating it manually, we obtain the default authentication manager from Spring authentication configuration now. Now we come to the most important part, that is the security filter chain. So uh, every incoming HTTP request passes through this filter. So basically, to reach the controller, it has to pass through this security filter chain. Now, first, we are here disabling the CRPF. Since we are using a JWT based authentication, instead of session, we don't need CRPF protection. So we disable it. Now, session manager. So what this will mean is that uh, the server will never create or maintain user session. So every request must contain a valid JWT token. Then here we define the authorization rules for our APIs. So all authentication related to these endpoints, such as login and registration, are public and can be accessed without using JWT. Then every other endpoints require authentication if a valid JWT is not provided. So it will come from this path, then permit all, else authentication will required. Then the authentication provider. So here we register the authentication provider we created earlier. Then finally, we register our JWT authentication filter. So it will execute before the Spring Security default authentication filter. So we will see what actual we have to declare in that particular file. After the updating that file, this error will not anymore. So now our Spring Security configuration is now complete. Now we have connected the password encoder, authentication provider, and authentication manager. Then also we have configured the authentication rules here, and now JWT filter is also configured into the class. Now we in the next video we want to build a JWT authentication filter. Till now we have just connected it, but in next video we are going to see actual what it is.